Welcome everyone, I'm Kevin Nguyen. I used to do FCC for 2 years, but now I graduated from high school. So this is about programming. So I'll kind of go into what is programming, how it works, so some things you kind of do with programming, and I'll kind of tell you some of the resources you can find online. And then if you have any extra time, I'll kind of walk you through to some of the basic programming that you can do. So what is programming? To put it simply, programming is a set of instructions that tells a robot what to do. Without it, the robot would just sit there on the field and would do nothing. So programming allows it to move and drive. So how does the program work? It all starts with the control hub. It's considered the brains of the robot. It stores the code, all the code that's stored is in the control hub. It communicates through Wi-Fi. So you're connect through Wi-Fi on your phone. It's the same way here. You will actually see the Wi-Fi network on your phone once it's powered on. It also contains an IMU, which I'll talk a little bit about later. So accessing the code. Usually you will have some kind of computer, and one of the ways you can communicate, like I said, is through Wi-Fi. You'll create the code on your computer, and you can upload it through the Wi-Fi onto the control hub. Usually you'll have a driver station app that you can download. You can use an Android phone, but but one of the things that came out recently, I think it's the second year that we've had this, is the driver station, or not the driver station, the driver hub. And it'll allow you to have the driver station app on it. Oh wait, I was gonna say, so the driver station app will allow you to run the code through the match. So, three main programming systems that First kind of provides. So there's Blocks, on-bot Java, and Android Studio. Blocks is a drag and drop based system, while on-bot Java and Android Studio uses text-based. But the great things about Blocks and on-bot Java is that it's very flexible in what you can use. You can use like a Chromebook, you can use I think certain tablets work as well. Android Studio is a little bit harder because you have to use Windows, and it takes a lot more memory. Blocks is very good for new beginners as it requires, as it's a drag and drop based system. On-bot Java and Android Studio being text-based requires a little bit more skill and background in programming. Blocks and on-bot Java are very similar. Their resources provided by First, and you can use programs like TensorFlow and Euphoria, which are systems that allow you to sense in the game. Android Studio lets you use a variety of programs, one of them being Roadrunner. Just so you know, if anyone's new here, a game consists of Autonomous and Teleop. Autonomous is 30 seconds that allows that you run the code, and it will run the code for 30 seconds, complete tasks, while Teleop is driver controlled, meaning you will have two drivers that will control the robot using some kind of controller, whether it's Xbox, PlayStation, or Logitech controllers. There's a variety of controllers you can use. So, things you can do with programming. So, some of the things you can do is moving autonomous. I mentioned the IMU before. One of the things that IMU allows is to move by using angles. Without any of these, the easiest way to move is to tell a robot to turn the motor on, and when you tell it to turn on, it will move clockwise, and then you can tell it to run for a certain amount of time and then tell it to stop. However, the IMU allows you to turn, and it will keep turning until it reaches a certain angle. That's one of the things you can do with the IMU. It's it's kind of beginner level, and it's very easy for you to use, along with encoders. One of the things you'll see is that the encoders, you'll see that in this picture, the IMU is located here, and these small ports down here, they're for encoders. You can plug encoders in along with the motors, and it allows you to run motors using ticks, which is kind of like rotations of the motors instead of using time. So it kind of allows for more precision by using the rotations of the motors instead. So Roadrunner is very difficult. It's you will have to use Android Studio for that, but it allows you to use coordinates and localization in order to move, instead of just telling the robot to move forward or move backward. You can just tell a coordinate and a direction to face, and it will just go to that location. So it's very useful, but it's also very skilled. So some sensors and camera tools. I mentioned TensorFlow and Euphoria. TensorFlow is a camera detection system by Google, the one that first provides like a light system. So it uses machine learning for object recognition. A lot of people used cameras in TensorFlow last year to detect the team shifting element. And Euphoria is slightly different. On the field, you have 4 pictures, and Euphoria allows you to recognize those pictures and tell you where the robot is during the match. And then there are some other sensors. We saw some people use distance sensors last year to tell how far they are from an object or a wall. That's very useful. Color sensors, as it suggests, can detect color. I know one team used it last year to tell if they picked up an item, and their LEDs would actually change colors, letting them know if they picked up something. So it's a very cool thing that you can learn how to use. Okay, so now we're on to resources. First, provides many resources. I'll just open these links. All of this will actually be posted on the Oklahoma FTC Discord, which I'll have a QR link that you guys can scan later and access this PowerPoint that I will be uploading later on. So this is the resource library for programming. There are other resources that provide like programming, or not programming, building and team management down here. So if you guys ever want to use that, you'll see that they have guides for all 3 systems that I mentioned: Blocks, OnBot Java, and Android Studio. They are very long. They're over like 100 pages, but it does go into depth what you need, how to set it up, and a little bit into how to program it. And then down here, you'll see that they have computer vision and object detection. So they have TensorFlow and Euphoria for blocks, and then it talks a little bit about using a camera in order to combine it with TensorFlow and Euphoria so that the robot can kind of see during the match. So I've also linked a playlist that someone else made, but all the videos are by FTC. It kind of goes over to how you configure the robot, writing your first, and it goes a little bit into like sensors and gamepads. Down. So this is an FTC simulator. Anyway, hold up. So this is a simulator that first provided about a month ago. Still pretty brand new, but it's a very good resource if you want to learn how to program autonomous. You can either use Blocks or OnBot Java with this, and it has different games as well, along with last year's game. They said that they'll also provide this year's game once the game is released. So you might see later today that they might add Power Play onto this. You'll see they already have Great Frenzy, which was last year's game. So it's a very great resource for you to learn kind of like how to program robots and use it for servos. And I know there is also a grant with this for new teams. So if you're a new team and complete this, you can actually get some money out of it. So here's some other resources. So Rev Robotics, they're a provider for a lot of the systems that you use. So even though it has programming, it does have other resources that you can use. You'll see that there's an introduction that tells you about the control hub and the driver hub. And then there's troubleshooting, so if you have any problems, you can go to that section. The system overview, so it kind of goes over the specifications. Updating and managing. This is probably a good resource for you to use later on, because later on you are required to update your system for the control hub and I believe the driver station app. And it's a requirement that you have to update it for the game. So this will kind of like walk you through how to update it all. And then down below you have programming and sensors. So it will kind of go into configuration. Configuration is very important because it allows you to name each of the motors and servos, and those names can be called into your program, so you kind of know like which name goes with which motor. This is an initial setup guide provided by another team that I found. I found it to be very useful if you ever want to use this. It's slightly outdated, but it's still pretty good. Tells you kind of like the hardware behind it, how to configure. The expansion hub. Oh yeah, so the expansion hub, it's very useful. You probably connect it to the control hub. The control hub allows 4 motor ports, so you can plug in 4 motors, but you probably use 4 extra motors because you use 4 motors for the. You'll probably use 4 motors for the wheels, and you probably want motors for something else as well, I assume. So the expansion hub allows 4 extra motor ports with a total of 8, which is what is allowed in the game. So it's right here. It'll tell you steps to configure, your robot and name. So this is very important, and it does guide you through that. And then I'll say a couple last things. Remember that all the resources you have are online. They're there for you, and you just have to kind of navigate around it. Coding can be hard at first, but it's something that you can learn to do, and it takes time to learn. Right here is the Oklahoma FTC Discord. I highly recommend all of you join it. There are channels for building, programming, rules that you can ask questions. There are mentors out there for you to ask and help. They're out there, so I highly recommend that you guys scan this and join the FTC Discord if you haven't already. So I'll just give everyone a couple of minutes. If you want to scan this and join the Oklahoma Discord. Yes?
Hey, just a quick question on the autonomous mode when you were talking about it.
Yeah.
The easiest way to get the students started with it. You mentioned IMU. Is that kind of is that a program itself? What is that?
So the IMU stands for Inertial Measurement Unit. It's already in the control hub, so you don't have to do anything extra. It's basically something you can access, and it'll help you when I use it, I kind of use it for turning, so it kind of helps with angles and stuff. So instead of telling it to turn for 5 seconds, you can tell it to turn 90 degrees instead. Because you tell it to turn for 5 seconds, you may not know how much that is.
So it's like libraries, basically.
Yeah, kind of.
Yeah.
It's already there, you just have to access it. That's encoder. I talked about encoders and Roadrunner. That's something that you kind of have to plug in. The encoders are just wires that you have to plug into the motor and the control hub. Roadrunner is just a library online you have to access. But the IMU is physically inside of the control hub. Does anyone still need this? Okay, so with that done, I'm going to kind of walk you through some basic programming using the simulator. So this is the first one. So when you start out, it will give you a video on it'll kind of guide you through it. And you can always, re-access the video by pressing guide up the top. So you'll pull up the video, and then you can save it. Right now, this is blocks code. If you haven't seen it before, it's very simple. It's just a drag and drop system that you can put and attach. And then you just bring it back if you want to delete it. You can also switch to OnBot Java, which you will see is text-based. It requires a little bit more skill and background, but it's there as a resource if you want it. Just the thing to know that when you actually use this, not on the simulator, but on your robot, you can transfer from blocks to OnBot Java, but if you have an error on onbot Java, which is the line code, it won't actually let you switch back to blocks until you fix that error. But if you use blocks, it will actually have the onbot Java line code on the side as well, so you can kind of see both at the same time if you wanted to. So that's kind of useful. Now I'm going to kind of get into basic programming. So you'll see, so one of the things I can do is access, if we go actuators and DC motor, I can access some of the different things I can do with the motors. So one of the very first things I can do, if I do dual, I can set the power to the motors. One, motors run from, they go from -1 to 1. 1 being clockwise, -1 to being counterclockwise. There's also something called servos that you'll see, which will turn on a position instead of a power, if that makes sense. So if you're, I know this won't work, but I'm just gonna run it and see what happens. So you'll see that they move clockwise, and that's because the motors are facing different directions. So their idea of clockwise are different. And that's a simple fix through, we go actuators, DC motor. The one on the left is actually moving clockwise, but it's moving the wrong direction that we want. So we actually change the direction. Actually, I'll put this up here. My bad. There we go. So I'm just pass that. So if I change direction to reverse, you will actually see it should be able to run straight. And then I can go into the next level. So this is the same puzzle, except that the robot is facing backwards. Once it wants to load. So if I do the same thing, let's see, dual, set power, and I reverse it, the left motor, you will see that it will move in the wrong direction because it's faced in the wrong direction. You see that? So the one thing you can do is actually make it go the other way by changing these values to -1, because motors run on power that goes from -1 to 1. 0 just means it's just not running. So that's how you turn it off. So if I click run, you'll see that the motors go the opposite direction and it'll reverse all the way to the flagpole. This one is a little bit trickier. So this one is that you have to go across a curve. So I'm just going to make the motors go forward and see what happens. Set power. You guys have any questions? You want to just raise your hand? Feel free. If you have any questions? So I just run it. You'll see it hits the wall. Pretty straightforward. However, if I'm the one easier ways to do this is if I make the motor on the right one go slower, you can kind of see on this like demonstration that the left one won't have as much, or the right one won't have much power, so the left one will actually take over and kind of like turn the robot a little bit. So if I put it to power down, you'll see it'll kind of have like a small curve to it. So another way you can also do this is make it go forward and then make it turn right. So another way to finish this challenge is make the robot go forward. There's something called sleep. What sleep does is that it puts a pause on the code. So you'll see that it says 1,000 milliseconds, that's just 1 second. So I put this. So what I can do is that actually is that I can make it go forward for 1 second, and then I can change it so that it will just turn after. So I change this value so that it will turn. I'm gonna change that for, let's say, 1 second. And then this is also on a loop. So what a loop does is it'll run through this code and it'll repeat. So I'm just gonna run this and see how it works. Oh, let's hit the wall first. So maybe we gotta cut this power down a little. We'll put the time down. Just say half a second. You'll see that a lot of this is trial and error, and this is something that will happen when you do program the robot. You will mess up a lot, and it's kind of just you're gonna have to figure it out by going. Maybe the power sequence just hit the power 0.5. So it goes half the speed now. You see. 5. See, so it goes 0.5, then it turns, but it looks like it turned too much. And that's kind of like the thing about sleep. So it gives it a pause. So it will run the motors for half power for 0.3 seconds, and then it will turn for 1 second.
Now, would you be able to copy and paste this? Like, so like say you are doing the simulator for the current game. Can you copy and paste your code from this and put that into your actual robot?
This, we can't copy it.
Okay.
I know you can like highlight it. If I highlight this, I can press duplicate. I don't know. I haven't tried that yet.
Okay.
This is still a fairly new system.
Right.
It's only been out for like a month, so I haven't done too much.
So this is,
testing.
I mean, this is more gonna be for actually a training program.
Yeah,
Okay.
it's really good for training.
Okay.
And you also said that you could see the Java code at the same time, whereas,
So on my Java, you click right here. If I click it right here, you'll see this is the same thing, but just in line code.
and that's the code that you would actually put
This
into.
is the code that I put into. So it's set power for half, sleep
Okay.
for 300 milliseconds, and so on. So this is the same thing, just line code. It's a little more tricky, but.
But once you got the other to work, you could test it out with your Java then to see if you could put that in your robot, right?
Say that again?
That is what actually goes into your, for your robot at the end.
You can use either. These are the same. These are both programming systems. You can upload. It's the same code, and you
Mhm.
will upload the same code onto the robot.
Okay.
It's just a different format.
Okay.
Because block code is easier and easier to learn. That's why it's there. But they're the same format of code. It's just when you upload it, it'll be the same code. If that makes
Okay.
sense. It's just a different way of seeing the code, as this is a little more user friendly. I think I've put this far. I should go. Yeah, but it's a lot of trial and error. You just kind of have to figure it out. Save 350. Yeah, but once you complete the puzzles, it will actually have different tasks for you to do. There we go. It's a really great tool. Right now it's kind of just new. Oh, I already finished all of that apparently. But there's different things you can do. You'll see that there's sensors, there's different puzzles, gravity, so that's like using servos, I believe. So servos is slightly different, it's position. And then you have last year's game, and then this year's game should be uploaded later today when kickoff happens. You guys have any other questions?
So yes, so you talked about new teams getting grants, like doing this, so what do they have to do in order to be eligible?
Let me see. If we go achievements, FT Sim grant, so it says apply for 15 labels, and there's FT Sim puzzles, and then there's like, it has the requirements right here. I haven't looked too much into it, but I know it's there and you might wanna look into it. Yeah, and then please fill out this form to apply for the grant, and then I'll ask you some questions. And then here are the requirements, where everyone will look. So North American teams only eligible for new rookie teams have not already registered. Teams where this grant are not eligible for the need-based first rookie team grant. Only one grant per rookie team, so those are the requirements. Do you guys have any other questions?
Does this training simulation have stuff for the tie-out period, or is it more?
It's all autonomous.
More autonomous?
Cause for tie-off, you need a controller, and so you will have to plug into the controller, whether it's to your Android 12 or your driver hub. Yeah, so this came out, I think there's another simulator out there as well, but I haven't done too much with it. And I mean, I don't have anything else to say unless you guys have questions.
What did you program in when you were in FTC?
My first year we did blocks, but then I kinda had some background with it and it was very easy for me, so I got our team to switch to Android Studio actually. And so this year we're trying to learn how to use Roadrunner. It's very hard though, but we got on it's a base bot, and now later on the season we're hoping to apply that to like a competition robot.
Are you guys using DevBuilds for that?
Dev builds. Yeah, it's kind of like already, or Roadrunner is already code, or it's already in a library. You just have to like download it and use it. It's not too bad. Yeah, the ostriches helping us. Thank you. Back there, so they used it before, and there's not too many teams that use it. I think there were like 2 to 3 teams that used it last year out of like 60 Oklahoma teams. So not many people use it, but it's really good if you learn how to do it. I don't know anything else.
Good job.
Thank you.
No problem.